Here we end up with multiplication principle. Now let's see the combination, which is simultaneously using addition and multiplication. Let's suppose we got here to determine the number of license plates that can be formed with 3 uppercase letters followed by 3 digits, such that the first letter is either A or B. Now we got here that license plates with start with A, and we got X2 as the license plates that start with B. So in order to find the number of those license plates that start either with A or with B, then we need to find each one by itself. So the number of elements in X1, which is the license plates that start with A, is first of all one letter, which is A, multiplied by any letter from the 26th letter, then any letter from the 26th letter. Then we got 10 digits and 10 digits and 10 digits. So here we got the result as 676, 3 zeros. Now X2 is license plate shall start with B, then any letter from the 26th, any letter here, and any digits, any digits, any digits. Then we got that 6, 7, 6 and 3 zeros. Now in order to find how many will be starting with either A or B, then I need to find the union. So here we got that the number of elements in A plus the number of elements on B. So here we got that 676000 plus 676000. Now here we got that there is 135 2 3 zeros ways to form a license plate that's formed from 3 uppercase followed by 3 digits and start with either A or B. Another way to solve this problem is we can just identify the license plates, and then here we got that they are 3 letters, and here we got that they should be digits. So in order to find X, then I got here either it starts with A or B, then any digits, any letter, any digits, any digits, any digits. So we got here the same result, which is 135 and 2000 ways. So either we use this approach or the one before. Okay, now here, let's suppose I got the following item available for breakfast. There are 4 types of cereals, 2 types of juice, and 3 types of bread. Now we need to determine the number of ways a breakfast can be prepared if exactly 2 items are selected. So I'm saying this, then I can see that either I choose one from the 4 cereal or 2 juices or one from the 2 juices, and and the 3 bread, or 1 from 3 bread and the 4 cereals. So here I will got the available, the number of ways I can form a breakfast. So this one is equals to 4 times 2 plus 2 times 3 plus 3 times 4. And we got that this is equals to 8 plus 12 plus 6, and all of these are equal to 26 ways. Let's move to the last topic in this session, which is principles of inclusion and exclusion. Here we got that in order to find the union between two sets, then I need to identify the elements of the first set plus the elements of the second set minus the intersect between set 1 and set 2. Here the example will explain more this principle. So let A be the set of positive integers that are less than or equal to 30 and multiples of 4, and B be the set of positive integers that are less than or equal to 30 and multiple of 6. Now we need to determine the number of elements in A union B. What we do first we identify the elements of A. Now set A is all the integers less than 30 and multiples of 4. So the integer that are less than 30 and multiple of 4 is 4, 8, 12, 16, 20, 24, and 28. Here we got that A equals to, the number of elements in A is 7. Then B equals to all the integers less than or equal to 30 and multiple of 6. Then we got them as 6, 12, 18, 24, and 30. Yeah, so the number of elements in B is 5. Now we need to find the intersect between A and B. What are the elements they are in A and also in B, and they consider as a multiple of 4 and multiple of 6. Here we got that they are 12 and 24. So A intersect B is equals to 2. Now to find the number of elements in A union B, then we got that we need the elements of A plus the elements of B plus the element of A intersect B. And here we got them 7 plus 5 plus, sorry, here is minus. So minus 2, and the elements of A union B equals to 10. Let A donate the set of bit strings of length 6 that begins with 101, and B donates the sets of bit string of length 6 that terminate at 00. Determine the number of elements in A union B. Before we start solving this problem, focus in here. What do you mean by bit strings? We mean that all zeros and ones. So as the binary language. So A is all the bit strings that begins with 101. Then we got A4, A5, A6 as the following bit string. B is the A1, A2, A3, A4, and then it should terminate with 0 and 0. So the number here of A equals to, I got 1 digit at the beginning, 1 digit which is 0 at the second, 1 digit in the third, and then either 0 or 1, either 0 or 1, either 0 or 1, and here we got that the number of elements in A is 8. B equals to, it can be the first one either 0 or 1, the second 0 or 1, the third 0 or 1, the fourth also 0 and 1, and then it should be ended with 0 and 0. So here we got how many? We got them 16. Now before we find the A union B, I should find A intersect B. So A intersect B means it starts with 101 and ends with 00, which means I got only one in here that can be any option, which is A4. So the number of elements for A intersect B is equals to, first letters reversed, the second, the third, then it might be either 0 or 1, then preserved and preserved. So here we got that the intersect equals to 2. Now the number of elements in A union B equals to number of elements in A plus number of elements on B plus A intersect B. Again, it is minus, not plus. This is equals to 8 plus 16 minus 2, and we got that they are 22-bit string. We also have that if they are 3 sets, then adding the elements of each set minus A intersect B minus A intersect C minus B intersect C plus all intersect A intersect B intersect C. Now let's check this example. We need to find the number of 3 digits even numbers. So here we got 3 digits and they should be even number. And how I just tell that this number is even or odd, I need to look at the unit place. Okay, so here we got that 10 numbers starting from 0 until 9. Even numbers, they are 0, 2, 4, 6, and 8. And they equal to 5. Okay, now to consider that this digit is an even number, then I have to put in here the 5 even, one of the 5 even numbers. So usually when I have a question with a condition, we start with the condition. So here we got 5 numbers can be in the unit place, so the number will be even. Then we start with from the beginning. Here we said that we have 10 numbers from 0 and 9. However, I cannot put 0 at the 100 place because 0 in the left does not have a value. So if I put 0 here, then I will got 2-digit number. Therefore, we can put here either 1, 2, 3, 4, 5, 6, 7, 8, and 9, which is 9 numbers. Then in the middle, I can put the 10 numbers. So here we got that there are totally 9 times 10 times 5 numbers, which this is equals to 450 numbers. Okay, how about we got the same question, which is forming the numbers of 3 digits and they are even. So I need to make sure that in the unit place I got an even number, but it should be divisible by 5. So I got 10 numbers from 0 until 9. Then we got the even numbers, and they consider as 5 numbers, which are 0, 2, 4, 8, 6. Now I need to choose the only numbers, even numbers, that divisible by 0, and it is the only 0. So I can put here only one number, which is 0. So as usual, we start with the condition here. Then I can put the only even number that divisible by 5 is 0. So here only one digit can be in the unit place. Then in the hundred place, I can use the whole number except 0. So here we got 9. And in the 10th place, it can be replaced by any numbers. So here there are totally 9 times 10 times 1. And here we got 90 numbers. Okay, we need to find the number of 4 digits number divisible by 3 or 7. So again, we got how many digits here? 4. 1, 2, 3, 4. So 10 numbers. They are from 0 until 9. So I can choose these numbers in the 100, in the 1000 place. It can be either 1 or 2 or 3 or 5 or 6 or 7 or 8 or 9. Then I can put any number from the 10 number and here and here. So totally I have 9,000 numbers from 4 digits. Now I need to find the numbers that they are divisible by 3 and the numbers they are divisible by 7 and the number they are divisible by 3 and 7. Then we can find how many numbers they are divisible by 3 or 7. So from those two 9,000 numbers, I got that they are 9,000 divided by 3, 3,000 numbers divisible by 3. And the numbers are divisible by 9, they are 7. They are 9,000 divided by 7. Then we got as 1285.7142. So we can take the approximate, which is the number before fraction point, and here we got 1285 numbers divisible by 7. Now in order to find the number that divisible by 3 and 7, then I need to divide 9,000 by 3 times 7. So here we got that 9,000 divisible by 21. This is equals to 428.57, and here we got 48. Now to find how many numbers we got divisible by 3 or 7, then I need to take divisible by 3, which are 3,000, plus divisible by 7, and they are 1,285, and divisible by 3 and 7, which are, sorry, here minus 48. So here we got that there are 3,857 numbers divisible by 3 or 7. Alright, now let's move to the next example we have. Find the 5-digit numbers with distinct digit. And what do we mean by distinct digit? We mean that repetition is not allowed. So here we got the 5 digits number. So here I got 5 places. Alright, then I need to fill those places with numbers, and they should be not similar to each other. So in the first place, I can fill one of the numbers from 1 to 9. So here we got the range that I can fill is from 1 to 9. 0 cannot be filled here because it will not be having a value. Then here we got the remaining numbers. So from 1 to 9, we eliminate one number, so we got 8 number. Added to them 0. So here we can see that 8 numbers can be, sorry, again 9 numbers can be filled. So 8, removing the one putting here, adding to it 0. Then we got 8, 7, and 6. So totally we got how many numbers with distinct digit? We got 2, 1, 2, 1, 6 numbers. All right, so let's check this example. Hey, we need to find the number of possible integers that they are less than or equal to 500, and they are A, B, C, D, E, F, G. We got like those missions. So here we got that there are 500 numbers. In order to find the from this 500 number how many they are divisible by 3, then I need to just divide 500 by 3. Then I will got 166.66. Then we just take the number before fraction point. So here we got that there is 166 number divisible by 3. For B, we got 500 divided by 5. And if we divide 500 by 5, then we got 100. And yes, from this range, there is 100 number divisible by 5. C. In the 500 numbers, they are, if we divide it by 7, we got that they are 71.42 numbers considered as divisible by 7. And if we take the point, then we got that they are 71 number. Same question, different missions. We need to find the number they are divisible by 3 and 5. So to do so, I need to find the numbers less than or equal to 500 and they are divisible by 5. And this is equals to 500 divided by 15. And here we got 33.33. So this means that there are 33 numbers are divisible by 3 and 5. E. We need to find the numbers divisible by 3 and 5. Oh, sorry, by 3 and 7 or 5. So first, we need to find the numbers are divisible by 3 and 7. So here we got 3 and 7. And then we just add to it the numbers are divisible by 5. Then we need to subtract the numbers are divisible by 3 and 7 and 5. So here we got 500 divided by 3 times 7 is equal to 32.8. Then 500 divided by 5 equals 200. And then we got 500 divided by 3 times 7 times 5 is, sorry, here we need to minus 4.76. So taking the numbers without fraction point, we will got 190. So we'll delete 0.8 and delete 0.76. Last one is finding the numbers that are neither divisible by 3 nor by 7. Okay, so we need space in here. So here we will got that for F. This represents that neither divisible by 3 nor divisible by 7, which means that we want the elements when description of not divisible by 3 and not divisible by 7. So if we just replace this with its original, then we will got that 3 union 7 intersect. Okay, this is equals to the element in the union set minus the element on 3 union 7. So this also equals to all element that I got minus divisible by 3 plus divisible by 7 minus divisible by 3 intersect and 7. So here we got that in the union, or the whole number I got, they are 500 number. Then the number they are divisible by 3 from the last example, if you get me, they are 166. And the number divisible by 7 is 71. And the number they are divisible by 3 and 7 is 23 minus 23. So here we got that 500 minus 240, and this is equal to 286. So I have the numbers, integers less than or equal to 500. They are 286. They are not divisible by 3 nor by 7. And here we reach the end of today's session, where we discussed about addition principle, multiplication principle, and principle of inclusion and exclusion. We'll see you inshallah in the next session. Thank you.